Hopefully you just came over from the first video. Sum and difference of cubes part 2. Hopefully you're looking at this and saying, Charlie, this is actually not a cube. But we're going to try to factor this so I can see a cube in there. I wonder if you can. So take a second, maybe pause the video and see if you can figure this out, and then see if you were right, because there is a cube in here, isn't there? So what I'm looking for is cubes. If I factor out u squared here, that goes, the u squared comes all the way out. If I factor the u squared from here, of course I had to factor from here, that would give me a u cubed, wouldn't it? So I'm just going to start this factoring a little bit. So I'm like, you know what, I'm going to do this. I'm hoping like hell this is going to work. So here, and I'm going to factor out a u squared. Then I'm looking at this, and if I factor this in half, if I factor 2 out of this, this will be 8. And 8 is a perfect cube. And now if I take that same factor out 1/2 here, that's 125, that's a cube, isn't it? So now I'm saying, isn't this true, that 8u cubed minus 125? So I'm sure you were saying, what are you talking about here? What I'm wondering is, did I get that thing out? First off, do I have all the pieces? Does it still work? Is it still true? 2 times 8 is my 16. 2 times negative 125 is my negative 250. U squared times u cubed is u to the 5th. U squared times negative 125 is, 2u squared is negative 250u squared. So it does work, doesn't it? Okay. Now what I'm hoping is that you're doing this. From here, you're going, you know what, I can see where you're going to get a cube out, because this is going to make things easier for us. Because here now we have difference of cubes, not Department of Corrections. Yes? So I'm going to take this, and I'm going to start working on this. And I'm looking at this, and I realize what I have here is I have 2u cubed. It's a little bit weird for a second, but remember that exponents are distributable over multiplication, and 2 to the 3rd power is my 8, and u cubed is this u cubed, isn't it? And it's minus 5 minus 5 cubed here, isn't it? So my value of A is 2u. My value of B is 5. So now I'm going to use the equation that we know, which is that, right, we get A minus B times A squared plus AB plus B squared. And we talked about in the last video that this is formulaic here, right? So I'm just going to fill in the blanks here, and we get A, which is 2u. So here's our 2u, minus B. B we said was 5. And then A squared, right, remember, here this is A squared, but it's 2u squared. So that gives us 2 squared is 4, u squared is u squared, right? Plus, it says AB, so 2u times 5 is 10u, isn't it? 10u, right? And B is 5. 5 squared is plus 25. Now what is important here is that I don't forget that I had this piece. I'm going to bring this piece back over here and give us our 2u squared, right, as our final answer right here. Alright? And I think that works out good, doesn't it? Oh, wow. I put B was B. B is 5, sorry. And somebody's thinking, I got him. I'm going to send him this comment. Still send me the comment. I'd love to hear from you. But and 10u plus 25 worked out good, didn't it? All right, can we try just one more? This is going to really pay off for you. I know that it is. So this is a similar kind of problem. Let's see if we can solve this. So try to solve this problem. Solve 2x to the 5th plus 24x is equal to 14x cubed. This problem looks a little bit daunting because it should have said x. Sorry, it should say x here. This problem looks a little bit screwy because it's kind of all over the place. When I get something like this, what I do is I just set the whole thing equal to 0. So I'm going to take negative 14x cubed from both sides, and I'm going to rewrite this as an equivalent equation of this 24, x minus 14x cubed is equal to 0. What do we? Oh, we can factor out greatest common factor. We can factor out 2x, can't we? So we factor out 2x. So factor out 2x, and then if you don't mind, I'm going to change the order of this a little bit. This will be x to the fourth minus 7x squared plus 12. Isn't that right? Is equal to 0. Now this is going to become difference of squares, isn't it? Difference of squares. And if you're sitting there going, what are you talking about? Make sure that you know this rule, and then we'll apply it a bunch of times, because that's what we're doing here. Is what makes people really good at math, especially at algebra and calculus, is that they really recognize patterns real well. So if we can do that, we got this thing beaten. So what I'm asking you to do, I guess now, is agree with me on this. Do you agree that x to the fourth power, is really the same as x squared, right? It's the x1 is distributable. 2 times 2 is 4, gives us that back, doesn't it? And do you agree that x squared is worth x squared? And then what I'm going to ask you to do, if you don't mind, is this thing that it's actually a thing that's used a ton in calculus. It's just called algebraic substitution. And what I want you to pretend just for a second is that I'm not crossing this out. I'm saying that this is x here, right? And that this is x here. So if you look at it in a weird way, now we have x squared minus 7x, don't we? Hopefully you can get what I'm talking about here. So I'm going to leave this 2x here, so there's that 2x. And then I'm going to start to factor this. I'm going to factor this thing a little bit. And I'm just going to use good quadratic factoring. So I'm going to have x and x. But remember, our x, the dotted x, is really x squared, isn't it? So I'm going to go ahead and admit that and say, well, you know what, the inside piece here is actually, look, I wonder if you can see this better this way. I'm saying this piece is my x value, and when I go back in there, I'm like, you know what, that is x squared. That's stupid. Sorry, that is x squared, right? The inside piece, right? And then this is the same thing here, so this is also x squared. And look, remember, we have x to the fourth here altogether. X squared times x squared is x to the fourth, isn't it? We got that back. Now, the same stupid game we play all the time with factoring in Algebra 1. I need two numbers. When I multiply the two numbers, I get positive 12. But when I add those same two numbers, I get negative 7. And those numbers are negative 3, aren't they? And negative 4. Right? Remember, we're solving this, so it has to go to 0. And then what I'm going to do is I'm going to ask myself this question. When is x squared, when is 2x equal to 0? Well, x is equal to 0. When is this equal to 0? So I'm going to pull this out, and I'm going to say, when is this equal to 0? So x squared equals 3, and x is equal to plus or minus the square root of 3. Isn't that right? And over here, when is x squared minus 4 equal to 0? Well, x squared is equal to 4. X is equal to plus or minus 2, isn't it? So we have negative 2 or plus 2. And these are the roots of this function. And look, this is a fifth, right? This is a fifth degree polynomial. And look how many roots we have. 1, 2, 3, 4, 5. We have all of our roots here. So we have this thing solved. Good work. Good work. I know it's a pain, but it's worth it. It's going to pay off for you. Keep doing it.